Okay, this is 6-3 video, Chapter 6, Lesson 3. Please open your textbooks to page 457. And just to reiterate, I expect you to be writing and taking notes on everything that I tell you to do in the video. So today we're going to solve equations with rational coefficients. Well, there's two big words here that we need to review. What does it mean to be rational, and what does it mean to be a coefficient? Well, first let's talk about coefficient. Coefficient is the number in front of the variable when you're multiplying. So in the term 2x, 2 is our coefficient. So now we're dealing with things that are rational and a coefficient. So when this number in front is a rational number, well, 2 is technically an integer. It's one of those really easy numbers, a positive or negative whole number. So a rational coefficient means rational, the root word is ratio. And if you think of how we write ratios, like the ratio of 2 to 3, we could write as the fraction 2/3. So rational is a fraction. So we're dealing with things that have rational coefficients. Okay, so to set the stage here, we're going to look at this real world link. It says 3/4 of the students in Aliyah's class belong to a social network. So 3/4 belong to a social network. There are 15 students in her class that belong to a social network. Okay, so if this bar represents her entire class, why do you think we divided it into 4 parts? Well, we chose to do that because we were looking at 3/4 of them. So the first thing we want to do is it says 3/4 of the whole class is in a social network. So we're going to take a look at the 3/4. So lightly shade 3 out of the 4 boxes. That's the part that belong to a social network. But then it goes on to say there are 15 students in her class that belong to a social network. So what that means is that what we just shaded is equal to 15. Okay? So with our bar modeling, we've got equal parts here. So each of these boxes have to represent the same value. So we have 3 boxes that equal 15. So doesn't that make 1 box is equal to 5? 5, 10, 15. So this box is the same size. And the question is, how many students are in her class? Well, based on that, 5, 10, 15, 20, we would have 20 students. Okay. All right, turn the page. All right, so we're going to begin solving equations just like we did the other day, but this time the coefficient is going to be rational, a messy number, a fraction, a decimal, something that's not necessarily super neat, and one integer value. So if you think about what we did yesterday, 16 equals 0.25n. Again, to get n by itself, we have to get rid of multiplying by 0.25. So what we do to get rid of multiplying is we divide both sides by 0.25. Remember that when you divide anything by itself, that cancels to 1. So we're left with n equals, and then we actually do that calculation, 64. So let's go to the bottom of the page, or actually the middle of the page, A, B, and C. So we find our variable. M is being multiplied by 0.8. So we have to get rid of multiplying by 0.8. So we're going to divide both sides by 0.8. And this is the one time that I want to see this underline bar, because this means division. Please cross out the 0.8s And we're left with m equals, and then you actually do that calculation, 64 divided by 0.8 equals 8. Okay, let's look at B. So locate the variable, decide what's being multiplied by it, and since we're doing multiplication, to undo multiplication we need to divide. Now why do we divide by negative 2.8? Because we want these two things to cancel, so you have to divide by the exact same amount. If it's negative 2.8 divided by negative 2.8, negative divided by negative will be positive 1, and that's what we want. So we're going to show this work. You're going to cross out the negative 2.8, and we're left with P is equal to, and when you do that calculation, positive 4.2 divided by negative 2.8 is negative 1.5. Okay, please pause the video and do the same thing for C, and I'll check that at the end. Okay, let's look at example 2. Jaya's coach agreed to buy ice cream for all of the team members. Ice cream cones are $2.50 each. Write and solve an equation to find how many cones the coach can buy with $30. So he's going to do $2.40 a certain number of times until it equals the money he has, 30. So notice in our book, in red here, we're dividing both sides by 2.5. Comes out to be that he can buy 12.5 cones. Well, let's think about this answer. It says, how many cones can he buy with $30? Will a store sell him half of an ice cream cone? No, they won't. Well, this is 0.5, so can that be rounded up to 13 cones? Well, let's try it. 13 times 2.4, if you multiply that, you're going to see that that's over $30. So in this case, we only can buy 12 cones. And we're still going to have a little bit left, but we're going to use our $30. Suppose the ice cream cones cost $2.80 each. How many ice cream cones could the coach buy with $42? So can you please pause the video and write the equation? Okay, check your work. You should have had 2.8 times some number equals 42. Then we're going to solve this by dividing both sides by 2.8. And we get that this coach can buy 15 cones. Okay, that's how you deal with decimal coefficients when the first number is a decimal. But what happens when it's a fraction? So if you look at 3/4 x equals 12/20. Notice our coefficient is 3/4. So we want to get rid of that. So over and over the last couple of days, what we do is we divide by this number. We divide both sides by 3/4 because that would cancel. But then if you look over here, doesn't this look like one of those nasty complex fractions that we had on the exam? 12/20 divided by 3/4. Ugh. Right? So what we ended up doing when we had 12/20 divided by 3/4, didn't we do keep, switch, flip? And we ended up multiplying by the reciprocal of this number. So this is what we're going to do right off the bat. We're going to realize that this is a fraction, and we're going to say, well, we don't like to divide by fractions because it's ugly. So the same thing as dividing by 3/4 is to multiply by the reciprocal. And we're going to do that same thing on both sides. Notice what happens to 3/4 and 4/3. When you multiply them, do you see that they all cross cancel out to 1? And we're left with 1x And then up here, notice the 4 and the 20 cross cancel to 1 and 5. The 3 and the 12 cross cancel to 1 and 4. And we're left with x equals 4/5. Okay, well, what happens if the fraction's negative? When you flip it, does it still stay negative? Yes, it does. So if you look at this work, negative 7/9, we're going to multiply by negative 9/7 on both sides. Notice that everything here cancels out, the 9 and the 9, the 7 and the 7, and we have negative times a negative, which is positive d. And on this side, we're multiplying negative 9/7 by 5, so put it as 5/1 so that you can see that. You multiply straight across to get 45, straight across to get 7, and you get an answer of negative 45/7 or negative 6 3/7. Okay, let's go to the bottom. We're going to put a time sign right here. What do we have to multiply 1/2 by to get it to cancel out? Well, we multiply by the reciprocal. And we do that on both sides. So we get x equals 16. Let's look at f. We're going to multiply by the reciprocal of negative 3/4, which is negative 4/3. We're going to do that over here. Negative 4/3 and 3/4 all cancels out, and we're left with just x. Over here, I can cross cancel the 3 and the 9. So 3 times negative 4 is negative 12. Please pause the video and do G. Make sure you're showing your work. If you don't have much room, you've got all this room up here, but I'll check that when you're finished. Okay, so I'd like you to turn the page, and I would like you to do 1, 2, 3, and 4, and then I will check that first thing tomorrow. Thank you. Have a good night.